We will now discuss the cosets of a group G. So what are the cosets of a group G? The cosets are nothing but the subset of a group G such that these subsets partitions the group G into equal sections of disjoint sets. So what I mean by this? Suppose uh, this box represents the group G or the length of the group G, suppose. Then the coset will divide or partition this group into equal sections like this. Okay. So the subset will partition this group into equal section, one section, then another section. This likewise it divides into four sections, for example. So this is one subset, another subset. So we have four subsets dividing the group G, and the union of all these subsets will give you group G again, where each subset is a disjoint. That means there is no common element in these subsets. Okay. So in this lecture, we will discuss about the cosets of a multiplicative group and the cosets of additive group. First, we will discuss the cosets of multiplicative group first. Okay. Say let A belongs to the group G, for example, then A into H is said to be a left coset and HA is said to be right coset. So we have two types of cosets. One is left coset and another is right coset. Say for example, if H is a subgroup, you remember H is not a subset. H is a subgroup of the group G, and you take any element A from G. So you remember that A may also belong to H also, no problem. So in general, you take an element A from G such that if you multiply the subgroup H with the element from the left hand side, it is called left coset. And similarly, if you multiply the subset H with the element from G from the right hand side, it is called right coset. Okay. Say for example, let us take a subgroup H containing the elements H1, H2, Hn. Then the left coset is denoted by this set where each element of H is multiplied by the element of by an element of G from the left hand side. Okay, AH1, AH2, AHn. Similarly, the right coset is denoted by this notation where each element of H is multiplied by an element A from the right hand side, so it is called right coset. So let us take a concrete example. We know that G, this is a multiplicative group, we know this. So let us take one subgroup of G. So this is a subgroup, you can check this is a subgroup. Now we are going to find the cosets with respect to this subgroup. So you take any element from G. Say first you take I is an element from G, and multiply each and every element of H from the left hand side. You will get these elements I minus I. Similarly, you take another element that is minus I, you get this set, and likewise you take minus I and multiply each and every element of H by minus I, you will get this set. Now we have how many cosets? 1, 2, 3, 4 cosets. So among these four cosets, we'll find that these cosets are either equal or disjoint. So what are the equal cosets? I minus I. This is also I minus I. So order doesn't matter in a set. So these two cosets are equal. Similarly, these two cosets are also equal. So in fact we have two cosets only. That is, one coset is I minus I, another coset is 1 minus I. Okay, we have only two cosets here in this case, and the union of these cosets will give you the group G. Okay, so any left or right cosets are either equal or disjoint whose union is the group itself. So as I have discussed, so any cosets will be either equal or disjoint whose union is the group G itself. Now let us discuss cosets of additive group. Okay, say for example, let us take an example of Z modulo 6. So this is an additive group. Additive group. So it contains elements 0, 1, 2, 3, 4, 5. So let us take one subset of Z6. So it is your choice. So I'm taking this subgroup. Uh, so H is a subgroup of Z6. Now you find the cosets of H. So what are the cosets? We are going to find the cosets of Z6 with respect to subgroup H. So first you take any element. So I start with 0. You can take any element of. So I'm taking 0. So 0, and you add 0 to every element of H. So 0 plus 0, 0 plus 2, 0 plus 4. You will get 0 to 4. And similarly, you take another element, that is 1. So you add 1 to every element of H again. You will get 1 plus 0, 1 plus 2, 1 plus 4. That is 1, 3, and 5. Similarly, if you take uh, next number, that is 2, you will get these elements 2, 4, and 6. We don't need to take the remaining elements because you see from these two cosets 0, 2, 4, 1, 3, 5. What you are getting, these two cosets are disjoint, and the union of these two cosets will give you Z6 again, because 0, 1, 2, 3, 4, 5, all the elements of Z6 are given by the union of these two sets. So these two sets are the only cosets of Z6. Remember, this is a left coset. Left coset. So in this case, you will get right coset will also give the same set. That means in this case, a left coset is equal to right cosets. Okay. So once again, the cosets are 0 plus h and 1 plus h in this case. So we can also see one more example of additive, the cosets of an additive group. Say this one, Z modulo 12. So it has the elements 0 to 11. And you take a subgroup 4, generated by 4. So here H is 0, 4, 8. Here the subgroup is generated by the element 4. Now what are the cosets? What are the possible cosets of this Z12 with respect to this subset, this subgroup? So adding 1, 2, and 3 to the elements of this subgroup, it gives us 1 plus 4, means you add 1 to every elements of this set. So 1 plus 0, 1, 1 plus 4, 5, 1 plus 8 is 9. Similarly, 2 plus 4, 2 plus 3, and these are the cosets, because these are disjoints. These sets are disjoint, and the union of this set will give you Z12. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All the elements of Z12 is given by the union of these four cosets. Okay, so these are the required cosets of Z12, because this subsets partitions the Z12. Okay, partition means these are the disjoint, and the union of this subset will give Z12. So we can say that this subset partitions the group Z12, or the union of this subset will give Z12. That's why these are the cosets of Z12. Okay.